Okay, so we're asked to find the domain and range of this function, right? What are domain and range? Yes. What values can x be? What values can y be? Okay. So in this particular function, it starts here, does a loop-to-loop, and we want to know what values can x be in this function and what values of y can we have in this function. Okay. So what do you think? What are our x values? Is it all real? Usually it's all real, right? Okay, because we're not necessarily limited. Do you see an open circle here? Yeah. Okay, that's the starting point. It says it can almost become this point, but it can't quite get there. Okay, so it's like the start of the segment, but it says, hey, you don't actually get to become this. Okay, and do you see this closed circle down here? It means that it can actually become that value. Okay, so what is the smallest value that x gets to be side to side?
-1.
-1. Can it be smaller than -1?
A little bit.
A little bit. In fact, it can almost be -2, but can't quite touch it. Okay, so our domain is going to be from -2, but it can't be -2, right? It has to be bigger than -2, but not touching it, so I'm not going to put an equal sign below it. And then how large can x become? What's the biggest value of x?
4.
4, good. Because that's the largest value it ever gets to be. Okay? Now, how about the range? How about the range? Yes.
Would it be like before, like less than or equal to?
Thank you. Thank you. Good catch. Okay? Now, what about the range? What's the largest value that y can become? Almost 4, right? Can't touch 4. So we don't put the equal sign beneath it. What's the smallest value y becomes? -2. Can it be -2?
Yes.
Yes. So we want it less than or equal to -2. Now, did I write that right? No. Okay. It's easy to write it from left to right as an x, right? From left to right, we get larger. Y starts low and goes high. So when we read, we typically read from the top to the bottom. We have to think about that and say, nope, I got to start from the bottom to the top. So our range is not this. It is from -2. It can be -2. And it cannot quite get to be 4. Yes?
What if we put in -3 for x?
So if we put in a -3 for x, it's not defined. There is no graph there. They've only defined it for certain values. So what they're saying is things like, wind generation of electricity. Did we ever generate electricity by wind that we actually measure on the grid in the 1970s or 1960s or 1950s? Did we have those great big wind turbine towers? No. Did we have nuclear energy prior to World War II? No. So those points don't even exist because it didn't happen at that time. So what they've done is they've defined this particular graph to say that it occurs between the values of -2 to 4 for x, and y's between -2 to 4 for y's as well. It just doesn't exist anywhere else. Okay? Everybody go with that? All right. So that's our first example. All right. Definition of a function. Get the audio going here. Actually, you don't probably need audio on it, so let's play it. Now, yes. Yep, I'm going to try to put this video out there on the website for you. Okay? That way, if you need to go back, pause, and repeat, you certainly can. We'll see how it works. Hopefully, it records well. All right, so a function. I always think of functions and I think of a machine. Okay? When we talk about a machine being functional, it's working, right? My best example of a machine that's functional would be a soda machine, a pop machine. So you get to see my husband here in just a moment recording him going to the TD Ameritrade pop machine and sticking a quarter in. They subsidize their soda. You only have to pay a quarter for pop there. Okay, so cheap soda. So what we do then is we say, okay, when we put in a coin, we expect to get a soda, right? Some camera, right? Okay, coin goes in, soda comes out. Machine's functioning, right? Okay? But what would happen if you put in a quarter and nothing came out? Would the pop machine company care? They're making money, right? What happens if you put in a quarter and 2 cans come out though? Then they're gonna have a problem, they're gonna come fix it, right? Okay, so here's the situation. Everywhere we see an X, we're gonna sub in a 2. So 2 times 2 is minus 3. So I put in 2, out comes 1. Is my machine functioning? Put in a quarter, out came a soda. Okay, here comes the next one. I'm putting in a 4. What's going to come out? 5, right? Here comes the 5. My function machine is functioning, right? Magic. Sleight of hand, here we go. 1 input, 1 output is a function. For every X that's going in, 1 Y comes out. Uh-oh, here we go. Change the function machine. Now I'm putting in 4. What's going to come out? 2. In comes 4. Out comes 2. Here comes my pop. Uh-oh. Something stuck to it. There came a Coke in addition to that Coke Zero. So that's not a function. Because it's the square root of 4 negative 2 as well. If I put in 25, what's coming out? 5 and negative 5?
No.
Okay, so that's not going to be a function. 1 input, 2 outputs, not a function. Okay? All right. So, inputs, outputs. If I put in 2 and 17 comes out, I put in 3 and 14 comes out, I put in 3, but 11 also came out, and I put in 4 and 11 came out. Is that a function? No, because we had 2 Y's for that same X. Okay? Yes?
It's okay for like 2 different numbers to have the same number.
Absolutely. Yep. I can put in a dollar bill with the number 5 on it and a dollar bill with the number 7 on it in this serial number and get the same kind of pop to come out, right? 2 different X's, the same kind of Y, we're okay. How about this one? My domain here is -3, 7, 3, 9, and 2. 3 went in, 4 came out, 7 went in, we also got a 4 out. Is that okay? Yeah, 2 different X's for that same Y, we're okay. Everybody cool with that? 3 went in, 5 came out, 9 and 2 each gave us a 1. 2 separate quarters got us the same brand of pop, we're fine. Does that make sense? Okay, so this next one, C. Now we've got a graph and we have to decide if it's a function or not. What's happening here? Hard to see the numbers. This is 0, 4, 8, and 10, I believe. I think they're by 4s. So at -4 over 0 up, we've got 1 point. But what's happening here at 0? I've got a -3 and a +3, right? So is that going to be a function? No, because when I put in x, 2 cans of pop came out. Okay, not a function. So what they're going to talk about is a vertical line test. If you're given a graph and you can draw a vertical line anywhere on that graph and have it touch the graph in 2 points, that means you have 1 input and 2 outputs. And that's not going to be a function. Okay? All right, next one. Function? Yeah, for every 1 x, there's exactly 1 y, so we're okay. And the last one? No, because we can draw a vertical line and touch it in 2 different spots. Okay? All right. Going over here. So now they're going to ask us to find the zeros of the function, so we get some more practice with factoring. Okay. F of x equals x squared plus 2x minus 3. By the way, if you didn't remember factoring, is there another way that you can find the zeros?
I don't know what it's called, but yeah.
The thing that you learned, quadratic formula, good. The thing that you learned a little song about probably, right? Nobody learned the song? You weren't ready for a song? It's like Pop Goes the Weasel.
I'm not ready.
Not ready for the song? It's gonna get stuck in your head. It will get stuck in your head. And I may have to delete that part of the song, of the video out, but we'll see. X equals -b plus or minus the square root b squared minus 4ac all over 2a.
Yeah.
Want to sing it together?
Well,
No? Okay. But we're not going to take the time to do the quadratic formula here because we can factor, right? X and x. Factors of 3, we're reading it backwards. Factors of -3, or I'm sorry, of 3 that subtract to get 2. 3 and 1. And we want it to be a +2, +3, and -1. So if that's going to be equal to 0, so far so good, right? Then we're going to say that x is -3 or 1. So that got us where the zeros are for y. Now we've got to find the zeros for x, right? So, or what values of x get us a 0 for y? Now what values of y will have a 0 for x? So here's the easier one. Plug in 0 everywhere you see x. 0, not a 6. And what is y? -3. So when x is 0, y is -3. And when x is -3, y is 0. When x is +1, y is 0. Okay? Those are the zeros. Places where it crosses the origin. I'm sorry, not the origin, the axes. And this is what it looks like. Were we right? -3, 0. 1, 0, and 0, -3. Okay, so you can always verify your work by putting it in a graphing calculator. All right, find the zeros of this function. Throw a zinger at you. so we want to know if we can make y be 0, g of x equals 0, then we're going to have the cube root of x minus 2.2. And that was hideous, I'm sorry. Too bright. I need to change my pen to white. I think I can do that. No, maybe not. Thank you. If I can find it, it's not oriented properly. No tech support, go away. And we'll deal with it later. Okay, so we'll get back to it. I think that was better. So how do we get rid of a cube root?
Cube
Cubit. 0 cubed is 0. And this cubed is going to be x minus 2.2. And so when we get the x by itself, x is 2.2. So 2.2, 0 is one of our zeros. Now, if we let the x be 0, what's y going to be? Cube root of negative 2.2, okay? And we don't know that number off the top of our head, so we're going to get a decimal. Someone with fast fingers on your calculator, what's the cube root of negative 2.2? 1.3. Okay. Because negative 1.3 times negative 1.3 times negative 1.3 gets us roughly negative 2.2. Okay? So let's see what it looks like. I think I gave you an example. We only had 2 zeros here, right? One here and one here. Okay. Next example. Find the zeros of that. So 3x squared minus 2x minus 8 over the quantity x plus 3. Let's see if it simplifies. I'd like to get rid of that x plus 2. Maybe it's something nice that will simplify. Let's see if we can factor. Factors of 3x squared is 3x and x, right? Factors of 8. 8 and 1, 4 and 2. If I put a 4 here and a 2 here, I can get 4 and 2, which can get me 6, right? If I subtract them to get the negative 2. So I want my bigger value to be the negative 6x and a positive 4x can get me the negative 2x. And it's still only going to get me an x plus 2 down here, isn't it? So unfortunately, they won't cancel because they're not identical. But it did help me get some zeros, didn't it? Yes, sir.
Do you add them to get the negative 2?
Yes, so what I was doing is I was doing like a FOIL. First times first is 3x squared. Oh, thank you. Thank you. Perfect. Okay. And nicely now what's going to happen? Those guys will cancel out, won't they? Okay. So, but we have to be careful here because what's one thing absolutely that we cannot do in mathematics? What's our rule? Never, ever, ever. A lot of those. There's one fundamental rule. Never divide by 0. Okay? So we can't divide by 0. We can't have this be a negative 2 for x because it's going to cause a problem with the graph. It just doesn't exist. Okay? So what are going to be, or what would be my zeros? Well, if I let x be 0, 0, 0, negative 8, 0, positive 2, when x is 0, y is going to be a negative 4. Okay? And what are factors here that would make, or what would make the, for what values of, when y is 0, what values of x do we have? (4/3, 0), and then we would normally have one at negative 2, but that's going to be a hole in our graph because it can't become that. If we're dividing by 2 or by 0, we're going to have a problem. So when we look at our graph, it's going to be strange.
How could you do negative 4?
I'm sorry.
How could you do negative 4, like 3x minus 1?
I just said, let's make 3x minus 4 be equal to 0. And so if I add 4 to both sides, 3x will be equal to a positive 4, so x is 4/3.
No, it doesn't equal negative 2x in the very original.
Oh, gotcha. Okay, so outsides is going to get me a negative 4x. Insides is going to get me positive 6x. You're right. It should have been what I had initially, a positive and a negative. Okay. So our changes are positive. We should have these signs be changed. Getting close on bell time, and for people packing up. Okay. So assignment. On the website. It's on the website, so just go ahead and look. Yeah, I'll take copy of it.
Just 1.5 together, please.
Little bit, no, not really.